Assalamu alaikum everyone. So I'm here with Hassanal. Today I'm here to tell you about our project Rahbar, in which the members are Muhammad Usman, Ahmed Javed, Wadha Sadal, and Amna Zafar, which was um submitted by Sir Farouk. So these are the lines on the top: proposal, initial step, technical standards, project concepts, mechanical design that we create on Proteus, or some other software like EasyEDC. Here, if it can open, yeah, here you can see the design. So let's move towards the report. Simulation, integration, and system test phase. The testing was quite irritating, quite. On the top, we start on a turtle project on Proteus, which was task given by Sir Umar Farouk. These are the code. For the turtle. So this is our circuit 3D model. You can see. The work divided in our team is like the team leading are Muhammad Usman, and hardworking dealing was Muhammad Usman and Ahmad Javed. Whereas center interference was uh, Farwad Hasadal and Amna Zafar. And where if you talk about the project assembling, the assembling of the board or each component was done by all of us individually, and we also make individual PC, which we also seen uh, that tell you on my previous video. And software designing was done by Muhammad Ahmed and Osman. This is the timeline for our project. You can see. So let me give you a small introduction of our project. Basically, we was making a line for a robot in which can make a decision of walking or stop. Stop in condition that if it is something is in a way, like any obstacle having a red color. So for that purpose, we are using a color sensor, um, um, IR sensors, ultrasonic sensor, and storing the value of the memory, like where our board is going. Um, for that purpose, we use SD card. The key component of our project are sensor, microcontroller, and motors. You can see. Line forward board are equipped with a sensor that are capable of detecting the contrast between the lines and surrounding surface, like white and black for a contrast, and for color detecting we use um, color sensor. Microcontrollers we use Arduino Nano, and the other one ESP32. These are the motor we use. The motors we use are DC motors, and the drivers we use are LC293D. Okay, so come to the working principle of our project. The line forward board operates on a closed loop control. The sensor continuously monitors the surface beneath the tool, beneath the robot. When a sensor detects the line, it sends a signal to the microcontroller, of course, The microcontroller processes this information and adjusts the monitor speed according to the speed of the report and aligned with the line. If the sensor detects derivation from the line, the microcontroller makes the connection to bring the report on track. The list of feature and operation specification of our project that we use a 5 sensor, which you can see in our. Wait a minute. Sorry for this. Net is quite slow. Okay, why you are not opening? Okay, let me open. Load again. Please wait. Come on, open. Yeah, it is opening. You can see. Yeah, the ultrasonic sensors. These are the ultrasonic sensors. The IR sensor are there. And here one, two. Wait a minute. Let me tell you about. Yes. So that are quite weak. The encoders we use in our project, there's a specification of product to use the encoders for the motors. Yes, we use the SD card with ESP32 and the color sensor ESP32. We use ESP32 that it consists of Bluetooth and Wi-Fi module. That's why we use it. And for displaying our displaying for our displaying for our results, our voltage, our current values, our speed, RPM, we are showing on OLED LED display. Okay, let's talk about the operation. The capture line position with the optical sensor mounted at the front end of the report. For this combination of IRLG photodiode called the optical sensor has been used. Number two, it gives the sensing process of a high resolution and high robustness. Steel robot requires steel mechanism for tracking. Two motors, grounding wheel are used for achieving this track. The system has LCD display panel to show the distance that it covers. Close we have. On the detecting no black surface, the boat move in a circular motion until the line is found. Let's talk about the components we use. One Arduino Nano, one ESP32. These two are microcontrollers. One OLED display, one um, SD card module. Motor driver. I also tell you that L293D, 5 IR sensors, one ultrasonic sensor, encoder, voltage sensor, current sensors. Cages we use are plastic cages. 2x motor of having 3 volts to 6 watt capacity. Of course, jumper wire, head pins, resistor, capacitors, often on button, CPU and net as we use it in for chasing also, and we use also there for the heat sink. 3 rechargeable battery, connecting, yes. Project development processes. Developing a line for a robot includes a systematic process that includes planning, designing, building, testing, refining. Here are a step project developer process for creating a line for a robot. So let's move towards the step. Select the component. It's very important. What are you making and which component you have to select? Is they are easy to buy? Are they are available in our country or in our city? And what price should be? Okay, these are very important. First step will be to select the component. Choose the microcontroller. As in our case, we use Arduino Nano ESP32. ESP32 because of the Wi-Fi and Bluetooth module, and no doubtedly that Arduino Nano has its own importance of selecting. Um, yes, designs the circuit. We designed the circuit on easy EDA instead of Proteus. Assemble the hardware. Assembling was done by all of four, like me, Vadha, Amna Zafar, Ahmed Bhai, and Usman Bhai. The code write was done by individual, and then we combined the code. But basically, and more work was done by Ahmed. On me, that I done the color sensor. Uh, Sensor interference was done by me and Amna Zafar. Uh, Test and collaboration was quite hectic, like quite because we have to test many times, too much times. Optimization, spend the functionality optional, like if you want to make more functional, like in case of color sensor, while detecting only for red color, we can also detect the it's just code changing, little bit changing, so it's not very really functional, but the code will not be as compared to difficult as other Bluetooth control, line control detection, that's all. Documentation. Document the project thoroughly. Yes, it's very important. Like we are doing the project report document. This is very important. Of course, you have for FYP. For FYP, you have to know how to make the report. So let's move toward our block diagram, which was made on the software Smartra. It is also not downloading. Okay. I made the block diagram on this app, a type of app on a website, Smartra. It's very nice to make and easy to draw block diagram. It will help you a lot if you're doing for FYP block diagram. So there's a battery. Here battery conditioning going in a current sensor, and current sensor and voltage sensor are further going into AD0, AD1. The signal are going the voltage signal are going connected with current sensor, okay, as well as the regulated voltage, which is very important. Further on, the current sensor are going in the motor driver and the voltage regulated. I told you. First, from the motor driver, there are two motor we are using with the encoders. Motor one, motor two. I'm going in encoders. This is our Arduino. This is our ESP2 controller. Like our ultrasonic sensor are connected with trigger or eco pin. IS sensor are connected with a digital pin where TCRT500 are connected with analog pin. For transmission, like RX is going in TX and TX going they are going opposite in direction. So here we are using the color sensor in a digital pin OLED display in I2C pin. Our SD card is going SPI. Uh, this is our type of gyroscope MDU6050. That's all. So let me tell about the ultrasonic sensor as my big portion are on sensor interference. So let me tell you about the ultrasonic sensor. Ultrasonic sensor is a device that uses the ultrasonic waves to measure the distance between the sensor and object, of course, to detect our basically we are in our case we're using to detect. Okay? It's work on the principle of echolocation, similar to how birds imagine gate ultrasonic sensors are commonly used in various applications, including the power, industrial automation, and etc. I tell you about the working principle. Assumption of emission of ultrasonic waves. Ultrasonic wave sensor emits high frequency sound wave. Frequency include 40 kilohertz from translucent ARA piezoelectronic crystal. These sound waves travel through the air until they encoded object on their path. Reflection and reflection. When the sound wave hit an object, they are reflected back toward the sensor. Sensor receive and typically the same translucence from the emitted the wave detect the sorry detect the reflective wave. Time measurement. Third one is time measurement. The sensor measures the time it takes from the emitting the wave to travel the object in a bag using the speed of the sound in the air. The sensor calculates the distance of the object based on the time of the flight. Number four, distance calculation. Yeah, it's very important. The distance is calculated using the formula speed. Using the formula d is equal to speed of the sound into the time of the flight. Um, Division by two and number two, it was divided by two necessary because the time measuring includes round strips. These are the key features of our ultrasonic sensor: non-contact measurements, range, accuracy is good, good as compared to other. Its accuracy is much better. Output versatility. The ultrasonic sensors are versatile and can be used in a wide range of applications, including manning like detection, object detection, liquid level measurement, etc. Output sensor typically provides the output signal that compares to the distance measurement application. These are in using car indus- indus- industrial automation, liquid level measurements. This is a big. This is the pins I'm showing: VCC, trigger, eco pin, and ground pin. You can see these are our ultrasonic sensor. If we talk about the Arduino Nano, Arduino Nano is a microcontroller, microcontroller of Atmel Mega 328P microcontroller. It's a part of our Arduino family of open source software product designed to make electrosonic electrosonic a microcontroller. Yeah, yes. In short, uh, there's less time left. Let me tell you about little about the pins of microcontroller. Arduino Nano. This is our ground pin. Um, Analog pin, digital pins. These are digital pins on a specific ground. There are two grounds. digital spin, inverted digital pins. If we talk about the chassis, we use the chassis of two wheels of a plastic body, having the one rubber wire, aluminum derivations. Let me show you. Quite short time. About the IR sensor. IR sensor is a device that uses the interactive radiation to detect the presence of object. Okay. Um. Yes. So there's a type of IR sensor. Infrared proximity sensor, infrared distance sensor, infrared reflective sensor, infrared thermophile sensor. How the sensor work? Little bit short here. It should receive, reflect, absorb the reflective position. The presence and absence of reflective light is used to detect the object in surfaces. Distance measurement in distance sensor the time taken for a mutant light to travel the object and back is measured. These are the infrared sensor. The motor driver we use the features of motor drivers is motor driver we use is L29 3D. I tell you the previous also in previous. The features of our motor driver are HP bridge, dual motor, stepper motors, and voltage cranks, which is rating from 4.5 to 36 watts. Built-in diodes and enable the pins. You can see this is our the motor driver. We also use the TT gear motor, TT gear motor for the two side of our boat, having with two wheels. Effect to a specific type of gear motor is commonly used in robotic and let me tell you about the features: dual shaft, gearbox, DC motor, voltage range, having good voltage range, compact size. You can see in the picture. It's very compact and easy to use. It is small motors, small robot designing. Here we are using LM 393 IS sensor. Here you can see. Mhm. The modular combined infrared IR sensor, dual compactor IC, having other components to create the sensor system capable of detecting and counting rotation, enabling the measurements in various applications. IR sensor, LM39 dual comparators, potentiometer, indicator LEDs in already built in. Working principle of our sensor, reflecting the sensing voltage compression pulse generator. Pulse generating. Yeah, you can see it is the sensor. Good. Sorry. The SD card module for using storing the value of the voltage from and a path it was obeying, it was going on. A small electronic device that provides a convenient interference for using the SD card. Yes, it's module with a microcontroller, Arduino board, and other embedded. I'm telling you this. Different features. I am highlighting that SD card slot, SPI interface, which I also mentioned, voltage regulating, level shifting, indicators, LEDs, data logging. These are all. And the pin, there's a pin defined out for our uh, SD card module. This is our SD card module. Next move was the OLED display of LG. We are using flat panel display technology that uses the organic compound to emit the light when the electronic current is applied. Some advantages over traditional displays such as LD liquid crystal display, like including battery control, parametric, fast response over time, more flexibility in design. This is you can see. quick uh, tell, telling of the feature: organic material, pixel structure, contrast ratio good and very high, flexible and thin, while viewing of angle, response on time, force, efficiency. One important feature of it, efficiency. So there's the gear motor accumulators sizes. I mentioned voltage regulating, reduction ratio, wheel sizes, chassis sizes. These are for the chassis. The software and firmware design of Arduino Nano, operating at the wide volt input. This is family of at Mega 3828P, 328P, analog pin 8. These are the specification of our controller. And if we talk about ESP32, this is a powerful microcontroller having the part of the ESP8266 and ESP32 family chips, which is used in a wide range, working on 2.3.3 cores, having 36 input IO pin. Some RAM, flash memory, clock speed are given. These are also pins defining components in. These are the components. A type of state diagram that's here for our circuit. You can see that when it's 0, left side 2, this 1, left side. So what will happen? 0, this 0 0 0 0, of course 0 0 stop S, and if LS1, LIS0, CS1, CSI0, and only these three, SI1, SI3, and SI6 are doing is moving forward. And this like this, the right, left, top, right, forward. This is the detailed backlight I tell you, starting. This is the code of Arduino for the I, if you want. Yes, IR or sensors, and this is basically proper code. And starting from the IR sensor, this is the IR sensor variable, and then detecting for a black and white contrast line. The speed are this, and these are function for left, right, moving, right, forward. These are pin we are defining from inputs, output pins. This is the serial dot becomes very important, and it's the one important thing is that okay, the serial dot begin, the value of this thing will be same what are you doing for your controller. And also they are calling the functions here. If this is very simple, if all are 0 0, not equal to 9, not equal to then 0 0. If one of its last one is equal to line, it means one is moving to forward. And in further we are other conditions for moving it left to right, like forward right, forward left, and this you're seeing this forward left. The else talk about forward left here. In forward we are not moving forward. Forward in forward we have to move forward state, forward left, forward right. For using these we are controlling a simple logic, else if logic, and dealing with that. Time is much less. Mhm. Now, if we talk about our color sensor code, let me tell you. From starting, these are the pin defined by our color sensor. Um, sense for sensing, we sense the sensor individually on our module or microcontroller. So in short, there's very less time. My video is making up 30 minutes, so I have to concise it. These are indicated for red green colors. You can see here We have refined it if we guys using that high low pins for the startup. Uh, uh, in the starting, I use some values. We have to calculate which color I'm doing, the what frequency will be each range for minimum maximum. What did I have to check, and then I put these values. Now, these are the simple I'm using if else function for the values of minimum what we are having. If article senses found something or the values coming, and it will compare with the values which I already told in my code. That's all. This, and then it is showing the values high, low according to the controls, red, blue, and that's it. It's not moving. Yes, you can see the PCB layout our project. The final testing, yes, it consists of more than three, but we also mentioned three. Three states. Yes. We first checked our components separately, exactly, like individual levels. We check the each and every sensor and component. Is it working correctly or not? Then we assemble. On second stage, we test all the modules by placing them on a board exactly. By placing them on a board and check it's working properly. The what we are demanding is it's working according to that. Third stage is that we're testing the PCB board. We integrated the component of PCB while working, and after third stage we test a lot. I told you in the starting that testing are little bit hectic. This is the this is a picture of our report. Leading was going with Muhammad Isman. Hardware handling was going with Ahmed Javed, and sensor interference was done with Ahmed Zafran Walasadu. These are the things. And we're assembling the project on a PCB board was done by all our four at the individual level. Alhamdulillah, project was successful. The risk we take and using especially when using via PCB board of and component checking. It was very important component checking. If we not check the component direct put on our PC board, and it will give a big damage. So Alhamdulillah, this project goes very well. Alhamdulillah, Alhamdulillah. That's all. Thank you so much. Allah Hafiz. Take care.